Well, welcome. Good morning. I am Jeffrey Palermo, and we're a DevOps-Centered Software Engineering company here at ClearMeasure, serving the U.S., headquartered in Austin, Texas. And I'm here to present to you a DevOps roadmap that can help you get to software releases in mere hours rather than days or weeks or months. And so I'm really excited by the group that we have today. We have quite a large group here, and so I want to make sure that this is interactive as possible, as interactive as it can be, and all of your questions are answered. So if as we go through here, you can use the Q&A window in the Zoom software, and you can ask a question, and I will do my best to work it into where I am and get that question answered. But I will make the commitment that I won't close down the webinar until all of the questions have been answered. And we do a number of webinars, and every time there's some great questions. And so if you actually attend more than one of the webinar, even if it's of the same topic, you'll see some variances just because of the audience participation. So let's dive in as we cover this. But a common challenge sometimes, and this may be your boat. Your software releases are months, and you think, okay, we'll have a big release in September, and you see competitors and you see others around doing software releases really, really quickly. Now, they could be technology companies like Netflix or Spotify. You hear about Facebook doing so many deploys per day, and you think, oh, well, that's not me. But if I could just do a release more than once a quarter, or even more than once a month, if you tried to do that, or if there are some changes that are just so scary that you just kind of put them off down the road. These are common challenges. You're not alone. And just judging from the attendee list we have on the webinar, I mean, we have architects, we have director of development, we have some CIOs and CTOs and some lead engineers even. You all are responsible for an effective organization. You're responsible for getting things done. And you have a lot of engineers working for you and working in your organizations. And it's really up to your leadership. And so we're going to dive into what to think about and how to equip your organization to move fast, to shorten their release cycle, and at the same time maintain and increase quality. So by way of introduction, again, I'm Jeffrey Palermo. I'm your host for this webinar. I'm the Chief Architect at ClearMeasure, and we focus on Microsoft and cloud platforms and making our client teams world-class and self-sufficient. Traditionally, our clients are not pure technology companies. They come from all industries, and you're a representative swath of just a number of industries that have adopted custom software in order to compete. And so you need to have a software engineering capability within your company in order to continue to compete in the marketplace and get ahead. So I'm here to present a DevOps roadmap that can help your team move fast, build your software in a smart manner, and run your system with confidence. Now, regardless of the challenge that you are facing, I understand the important responsibility that you have, and as you ask any questions along the way, I'll work them in. And at the end, I'm going to give you my direct contact information if there's anything sensitive that you want to just reach out and ask directly. So the webinar is organized like this. We'll talk about the challenge, what it looks like, some of the symptoms there, common root causes for those symptoms, and then we'll dive into the overall structure of the roadmap. Then we'll dig into the details of each piece of it, and then we'll offer some ways that we can add value and provide assistance. Now, a special offer for all of you who are attending this webinar is a free copy of my new book. Now, this is a preview edition because it's working its way through the final proofing, and it'll be on Amazon.com soon. but you can order it right now directly from the book printer. And that's the URL right there on the screen. And it's called .NET DevOps for Azure. It is a prescriptive guide. Whereas if your team really doesn't know how to get started from a technical perspective, from digging in deep and what tools do I integrate, what products do I use, how do I put it all together, what happens first, second, third, what's the sequence of activities from source control all the way through production and production monitoring, and even integrating work tracking into all that. It's a prescriptive guide. It shows you piece by piece, and it comes with a working example implemented with Azure DevOps Services, so you can equip all of your engineers with this. And if you don't know why you would specifically do it a certain way, this book does not say, quote, "it depends." This book says 80% of the time, do it this way, unless you know a specific reason why you want to alter. So if you are interested in this offer, just reach out either in the chat or email me, or reply to Rain, who's our webinar moderator, and request a free ebook edition of the book, and we'd be happy to give it to you. All right, let's move forward. Okay, so as we transition from a slower release cycle to a faster release cycle, we don't want to end up in a situation where we're just shipping bugs to production faster. We need to increase our speed, go at a high speed, but we also need to maintain and increase quality. And so those two have to go together. And it's interesting to know that all the research that analyzes quality and analyzes productivity basically concludes that quality comes first and productivity or speed second. If you go after speed and don't achieve quality, you will not achieve speed. But there's a correlation. By achieving quality, speed just starts happening. So that's very interesting in research, but conversation for another time. So some of the symptoms that you might be familiar with, and chances are every one of you here has had some type of disruptive deployment, a deployment that's gone wrong, that's gone longer. You've had downtime, you've had customers impacted, or maybe you're getting ready for a deployment, but software's just not ready. There's problems with it, and so we have some delays. And then as a leader, you have a gut feel. You just know that something's not right, that something's that there's a risk there that hasn't been mitigated, even if you can't describe it because of your experience. And those are the things that we can see. What we can't see are what are the root causes that may be contributing to one or more of these symptoms, as well as other symptoms. And across working with so many of our clients in improving their overall development environment and implementing DevOps automation and filling in the gaps with their, what you think of as a digital manufacturing plant of software, where if you're going to build anything, you're going to set up some type of factory floor, some type of environment where you bring in raw materials in some place and you do some things, you route the work. There's a series of workstations, and then you have a finished product coming out the other side. And we are not in the mass manufacturing business. Probably the closest thing to a manufacturing analogy you can come up with is a manufacturing plant that builds fire engines, because no two fire engines are the same. Every single fire engine is a custom order, and each individual engine is built by a team, and it's a long process. So there's some dynamics there, but some of the root causes that we come across are on the bottom right here. Insufficient work environment is pretty common, where the workstations on the factory floor are not properly sequenced or not even exposed. They're just more figuratively, the team is kind of moving around and doing their best, but there's not a flow to the work environment. Also, an incomplete software process is common, where some people who have approval or need to be consulted or need to be a part of the design are not integrated into the process, and then they come after something's been built, and then they bring issues. And then measurement. If you as the leader hope to have control over the process, then it needs to be defined, and then you need to have measures in place. Just like if you provide a departmental report, either to the executive team, or if you're on the executive team to the board, if you have a board of directors, you provide numbers, you provide KPIs, you have a way to measure it. And the same thing with a software process. This is a process that requires tremendous investment, and so it really doesn't automatically go well unless it's treated just like any other part of the business, with a strategy, consistent execution, and a way of measuring it. So this is the conventional view of DevOps that we see in the industry, where, okay, we have an automated DevOps pipeline, and I'll tell you why we've made it so small in a minute. But you have the cycles, plan, code, integrate, package, release, operate, and then learn, and then it flows back into planning. And if if you're doing Scrum or extreme programming or one of the agile methodologies, a lot of these things are not new, but DevOps really focuses, instead of batching, it focuses on the lean concept of single piece flow, and just says, for every change to the software, for everything we need to do, these are the things we need to do: plan, code, integrate, package, release, operate, learn. And then we need to do and execute that cycle faster and faster and faster and faster, and see how fast we can spin this cycle. And it spins around the axis of the automated DevOps pipeline. And that is the base infrastructure. We need to automate everything that can be done by a computer, and only reserve for a human what a human has to do, what cannot be done by a computer. So when you think about builds and automated testing and static code analysis and the deployments and environment provisioning, those are all things that computers can do. And so they're targets for automation. And certainly when you say you're implementing DevOps, you're going to automate all of those things. And we do that tons for our clients, but that's not the full story. That alone is not going to yield what you're looking for. It's not going to yield the increased quality and the speed that you're looking for. And when it talks about speed, okay, maybe speed of automation, but the defects are still going to flow on through to production. And so the automated DevOps pipeline is only the start. And before we move on, let's just touch on the basics of that automated DevOps pipeline. Now, this is a highly shrunken technical blueprint for the structure and the flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy. It has continuous integration and a 3-tier deployment pipeline. By the way, you'll never have fewer than 3 environments, even for simple applications or microservices. You have to have at least one of each of the 3 unique types of environments in your pipeline. Now, we've done some other webinars that dive deep into the details of this model, but please reach out if you need more information on how to set up a software system for continuous integration and automated deployments. And by the way, not just the front end of the application, the database is just as important. It's part of the overall application. So if any of you, by the way, this is just the top third of this architectural poster that kind of describes it in detail. If any of you would like a digital copy of this full architecture poster, just reach out. Rain would be happy to provide that to you, and you can get it printed. It's formatted for Architecture D paper, so you can get it printed if you like it. 2-foot by 3-foot paper at your local print shop. So that's available as a resource. All right, so now I want to talk about the challenge in our industry, and let's move into our model. Imagine yourself as, well, let's consider an owner who's starting a mechanic shop, an auto mechanic shop. He has this vision. He's going to, he purchases this great location. He builds a beautiful new building, purchases great tools and new equipment, thinking, you know what, I'm going to do this right. Only the best will do. I'm going to invest what it takes. He goes to the local auto mechanic trade school, and talks to the dean of the school, says, I want to hire your top 7%. Only the best will do. You have a graduating class coming up. I'm going to pay what it takes. I want to hire the top of your class. And so graduation day comes, and he does hire at the top of the class, really smart, fast, intelligent mechanics, trained out of a great school. And they come and everyone's lined up in front of the building. And the owner comes out really proud with all the beautiful equipment, and the new graduates are excited to be working in this environment with a shop owner with the mentality of, we're going to do this right. Only the best will do. And so shop owner gives a speech and welcomes everyone, and then says, okay, we have a few days. Let's get set up. We'll have our grand opening. Let's get ready, team. And he walks away really proud of himself. And all the new graduates, top of their class, look at each other wide-eyed with fear, because they have no idea what to do. They were never trained to set up a work environment for themselves. They were set up in an environment that was professionally designed and set up by other people. Nowhere in the curriculum was it set up your own shop. And we have that same type of thing here in the software development industry. All of the coding schools, all of the computer science degrees. Heck, 22 years ago when I went through the curriculum, data structures and all kinds of algorithms, all kinds of classes that you go through, but there was not a class in how to set up your own work environment. And so we as leaders, it's our job to set up our teams for success. And this is part of it, making sure that we have a complete process, a complete work environment, thinking figuratively of what is our software manufacturing plant? What would the shop floor look like? What is the sequence of workstations, and what materials move from one workstation to the another? And who does those workstations? And which workstations are one person versus, a whole group of people? We have to think about those things because the people in our organization, the people long in the tooth, they learned it through the school of hard knocks, on the job training, making mistakes. But the people who, are who are more younger in their career, none of us were trained in that. And so I hope that this webinar is a start of that. But so we have all these layers that we're suggesting. Now we have best practices, defect removal, team workflow, architecture blueprints, and cloud operations as layers around the automated DevOps pipeline. We consider these layers to be part of the DevOps environment. Because if you just automate a way to promote code, you're just going to ship a bunch of defects really fast. So these other layers need to be part of the environment in order to spin that cycle: plan, code, integrate, package, release, operate, learn, spin that cycle faster and faster. And of each of these layers, you have to have a sound strategy. It has to be executed with discipline and have objective measures. It's not enough to say that you've equipped your team with, let's say, defect removal. For example, which, by the way, the strategy for defect removal is what methods you're going to employ. And you have to choose those wisely. Now, we benefit from the research of Capers-Jones, who's probably the best research synthesizer we have in the industry. And he spells out the combination of defect detection methods that are proven to achieve high 90% in defect removal. And so choosing the strategy takes the guesswork out of the process for our team. And by the way, those three methods are testing, static analysis, and formal inspections. And be happy to go into that more or contact me afterwards. But there's tons of defect detection methods, but the research kind of points to a few that are reliably effective. But let's quickly touch on all of these layers one at a time. And we will start with best practices. Now, on the top right of your screen, you may be in the beginning state, or one of your teams may be in a place where practices are not stated, they're not written down. If you went and interviewed every member of the team and just asked, hey, what are the best practices we've chosen for this project, you might get different answers. And definitely you're missing controls to guarantee the execution of those, and hence probably no measurement. But the ideal state across all of your teams would be that the practices are chosen. They're written down. Everybody knows them and they're applied, and you have controls, so that you can check that they're in place and that they're being done. They're being executed consistently. And there's a smattering of common best practices on the left-hand side. But it's interesting that there are so many practices that have been labeled best practice that it is logistically impossible to use all of the best practices on a given project. There's just too many of them. Some of them overlap. Some of them are orthogonal, but there's absolutely too many. And so if it's impossible to use all of the practices that have been labeled a quote best practice, then logically we have to come to a spot where we are choosing which of the best practices are appropriate for a particular project. And that has to be a sober decision. You don't have to make the decision by yourself, but you need to make sure that that decision has been made. What practices are we using? And just like with every strategy, a strategy is deciding what you're going to do, but it just as importantly, it's deciding what you're not going to do. So one of the best practices that's commonly selected is the use of stable, reusable components. And there's a lot of research around this going back decades, but this practice is known to drastically cut down on custom development costs. Some people call it build versus buy. In the .NET world, this is NuGet packages. This is bringing in libraries. This is using open source and commercial tools. And even among teams that have declared that they do this, when we go into clients, a lot of times we find large sections of code that could have been easily replaced by one of these packages. And we talk to the leaders of those teams, and they're often unaware that their team spent a significant amount of time writing a whole bunch of custom code that just wasn't necessary, and had missed a real opportunity to save significant chunks of schedule. And so it's one thing to say you do it. It's another thing to actually have a process where you can know that it's happening, as opposed to, developers like to write code. And I've been a computer programmer for 22 years and I like to write code. It's fun. I mean, you're building things. Just like you would say, hey, a carpenter likes to build things. It's natural. But as a leader, with trying to make your organization more effective, this is one of those things you got to think about. Now, the next layer is defect removal. Research shows that far less than half of the defects in a software system are defects in the source code. So here's the distribution. For every 5 defects that are found over the life of the software, 1.75 did come from the source code. But one of them, which is 20%, came from faulty requirements or analysis gaps or things that were just missed or wrong decisions that were made. 1.23, which is more than 20%, comes from a bad design decision. Then, okay, 1.75 does come from the code. 0.6 comes from errors in the documentation. And then 0.4 come from bad fixes. That's 10%, nearly 10% of defects come from an attempt to fix a different defect. Now, you can dig in more with these numbers in Capers-Jones's 2012 white paper, and you can search for it online. It's Software Defect Origins and Removal Methods. That's Software Defect Origins and Removal Methods. And so based on the type of software we have, we need to strategically select the defect detection methods and the removal methods that are shown in the industry to get us at least 85% defect removal and up in the high 90%, and then measure that those methods are applied to ensure that our team achieves and maintains this level. And by the way, if we measure ourselves and we're shipping 15% of potential defects to production, that is borderline malpractice. And so we need to know what our team's level is, quantify that, and then take action to improve it. So we talked about reusing build versus buy, pulling in NuGet packages. One of the interesting things is that there's a short list of major defect origins that's also in Capers-Jones's research. and there's a top 10 list, and the unapproved reusing of code from external sources is in that top 10 list. And that's basically pulling in a NuGet package or pulling in a library without talking to the team. And that basically it's in the top 10 list of defect creators. So that's super risky. What does that mean? Has any of your developers ever added a NuGet package or added a library without it going through the right design conversation? So, and NuGet packages are great for, it's perfect technology for packages that are strategically identified. But again, when we come into clients and we'll often find there's packages that have been brought in all places in the code, and the leader or leaders of the team aren't aware of all of them. And NuGet, it's not like the Apple App Store where Microsoft isn't even looking at these. Anyone from anywhere in the world can throw up some code, create a description of it, and put it on NuGet. So you want to make sure that every dependency, every library that you're bringing in is properly vetted in whatever way is appropriate for your team, and that it's known about. The next layer is team workflow. So most software project tracking tools use a Kanban board or columns or statuses to move a piece of work through the process. But we'll find with our clients that the tracked process in the tool is much less granular than what actually happens in real life. Maybe they have someone that needs to have a say in the design. There's a review process, or there's somebody that needs to be consulted, or any number of people outside of the developers that are somehow involved, and things are happening over email or word of mouth or whatnot. And it's not captured in the process tracking tool. And if you're using Azure boards or even Jira, and you don't capture a particular step, then you have no way of knowing if there's a bottleneck or if there's a problem with the smooth flow of work. And a huge symptom is, you can do a test, but of course you already know this answer if you're in that boat. If your developers were to not check email all day, who would be upset? Who would say, hey, why haven't you gotten this done? That's because work is flowing through email instead of flowing through the work tracking system. So that's just a quick test that you can do. But if the motion in the team doesn't reflect and isn't shown in whatever work tracking tool that you're using, then you'll have bottlenecks that happen. They'll remain hidden, and it'll just sap your schedule. So your complete workflow, when it's captured, when it's visible, it sheds light on every bottleneck source, and it enables your team to have a consistent and predictable flow that you can tune and measure. And oftentimes, by the way, in the book, in our book, .NET DevOps for Azure, we show a framework for the general structure of a Kanban board. So it doesn't have to be a mystery. You just look in the book and you can see the general structure. And oftentimes, a lot of folks have not started, in progress, and done. And maybe after in progress, there's some extra columns for testing or whatnot. But it's interesting that the most common stages that are not captured properly are the 4 unique types of design. And if those 4 types of design decisions are not made in a visible way, then they're going to be made by whichever developer happens to be working on the feature that's flowing through. And then you as the manager or leader won't have visibility into if those design decisions have been made, how long they've taken, what's taken long, what's taken too long. All right, the next layer is architecture blueprints. Now, Philippe Christian, in 1995, and at the time he worked for Rational Software Corporation, he has a white paper, and it describes an architectural model for emergent iterative architecture. And it's to this day, it's our favorite model for agile architecture. When you know that you're not doing a big bang, you're not doing a huge cutover, it needs to be incremental. You're going to have architectural transitions along the way, and this model is helps you describe what those architectural changes are. So it's called the 4+1 view model of software architecture. And again, the name is Philippe Kruchten, Kruchten, if you want to search for it. The 4+1 view model of software architecture. Here's a PDF white paper online, and it can get kind of dense, but it really comes to light in the last 2 or 3 pages of the white paper. So don't stop reading early. But man, I just love that model for iterative emergent architecture. And the bottom line is, strategically, you as the leader are defining what is being built, what is cleared for investment, and also what is deferred. If you have a to-be architecture or an architectural vision, okay, that's great. But how much of it is being built or changed this month? Well, there's your architectural transition version. And you can explicitly say, even though this is part of our overall architectural vision, all these boxes, whatnot, don't work on them because we're not doing them yet. And so it's a model for being able to describe that. Every professional that builds something uses design drawings of some type or maybe a model to communicate what is to be built. There's not anybody in the world that builds something in a team setting that doesn't in some way draw what's being built in some fashion. Even if it's a simple wooden patio or deck or a carport, there's a picture of it of some sort so that you can get the image of what the finished product is supposed to be in the minds of all the people building it. Because if you don't provide them an image, then each person's going to basically construct an image of their own just to help them out. And the images are not going to match. And teams that lack this are constantly struggling to get everybody on the same page. In our across our clients, we often ask how the system is structured, or, hey, do you have any architecture diagrams? And far too many times, of course, they say, oh no, we don't have them. And then we spend over an hour in a conference room harvesting the current architecture, which is essentially just the current shape of the system. Hey, how many processes do you have running across how many servers? That's the physical layer or the runtime layer. And then, okay, logically, what are all the pieces in a logical fashion? What are the directions of dependencies? And that's the logical layer, and that often maps to the Visual Studio solution of libraries and dependencies between assemblies and libraries. And then the process layer is what sequence does data flow through the system for the really common transactions? That's the process layer. And then the fourth layer is the development layer. Okay, what does the development environment look? In other words, what does the environment look like in order to be able to maintain, operate, and change the system? What are the tools that have to be installed on a developer workstation? What is the sequence of environments? Basically, the DevOps environment, soup to nuts, has become the umbrella for everything necessary to properly change the system. So we, oftentimes we help harvest it out of the team. Now, if any of you are doing an iterative process, if you're using Scrum and have sprints, a perfect exercise during a sprint review is to pull out the current architecture document and just ask, hey, is what we have now any different from what's depicted on this piece of paper? Hold it up. And if there's any differences, say, great, let's capture what that is and just do it on a whiteboard, do it on a piece of paper. It doesn't have to be a lot of effort, but it's a tool for team alignment. Okay, so the next layer is cloud operations. So operating the software system is how we help our users get the benefit from it. If it doesn't operate in a stable fashion, then the users can't do their job. It needs to be reliable. It needs to help them get their. It needs to fade into the background so that the people that depend on it can do their jobs. Nobody really wants to use software. They want the software to assist them. They don't want to have to serve the software's needs. They want the software to serve their needs. And if we rely on a user to report an issue that they're having problems, one, we're not going to get all the reports. And two, we're only capturing a subset of the information that is available. We need to make sure that our systems are observable. And if you're paying attention to DevOps conferences, a lot of the conversation is around observability, because the industry is still trying to figure out what that means, but it's a critical capability. Just like 10 or 15 years ago, the industry was having a huge conversation around test-driven development and why their existing systems, it was so hard to write unit tests, and what characteristics of a system made it testable. And now that conversation has died down, and everybody kind of accepts, yeah, automated tests would be useful, even though it's still not as adopted as it should be. But the conversation now, especially with people moving to the cloud, is, okay, how do I know what every part of my system is doing? And especially people breaking up monolithic architectures and having more and more processes running at once, and people adopting the microservices theme of architectural patterns. There's more and more independent processes that are running, and we need to know what everything is doing, not just as an individual processor running application, but also overall, what is our users' experience right now? And we need to see what they're doing and be able to query for problems. And many teams have some logs or some telemetry capturing some information, but it's not enough. And we find a lot of times someone with administrative access has to log into a production server to look through them. There's no aggregation. They're jumping from log file to log file. There's not any performance timings, no aggregation. The goal is to make the system completely observable, to know what it's doing. And to do so, we need to employ some of the practices of data warehousing. Now, probably a lot of you have essentially equipped some databases, whether it be a full data warehouse, or maybe just some databases with some star schemas and some denormalized tables to allow the business some intelligence about what their customers are doing. Well, we can do the same thing with the software system. We take a bunch of information, we stream it from every part of our system that's running, and we stream it to a centralized place. We centralize all of the logs. Then we layer on a querying capability on top of that and design the query so that we understand what's going on. Now, some tools make it super easy. I mean, whether you're on full operating system servers and you're using Splunk or New Relic or Stackify, those products are good. In Azure Application Insights is fantastic. Log Analytics is fantastic, and you can create queries and then compare them against thresholds and configure an automated alert when anything returns from that query that goes past a threshold. And so you can build up all of this intelligence around when something not quite right is happening and alert your team. But either way, it's not enough to rely on our users to really tell us when a problem happened. We need to know it. Otherwise, it's really going to be hard to move fast around this DevOps cycle around the outside of our model. So we've gone through each layer, and in order to spin this cycle faster and faster, yes, it does start with the automated DevOps pipeline as our basic as our foundation, but we have to think about and have these other 5 layers in our DevOps environment if we want to achieve quality and speed and go fast. And so it's not enough to automate the technical movement of bits in order to say, oh, I have an automated deployment. I can now deploy in hours and minutes versus months or weeks or days. But once we put together this full model, it really does help the team move fast and build the software in a smart way and run with confidence by having every element have some strategic decisions, making sure that it's being executed with consistency, and measure that you have the right strategy and how it's going. So we have plenty of stories on our website of the impacts that this model has been able to make, and we'd love to be able to see the impact that it could make for your organization. We hear of teams who move fast at Google and Netflix and Microsoft, but I am telling you right now, any of your teams can be just as effective when equipped properly. They really can. You have smart people, and they are eager, and they want to do this. They just need the skills, the tools, and the methods, and they will absolutely shine. And we love seeing that with our clients. We love seeing our clients be self-sufficient. And there's several ways that we can assist your organization. We can guide you through a project. There's three things. One, we do tons of DevOps implementations from an automation perspective and help implementing these layers. We also do a lot of project jump starts where you're starting a new and significant undertaking, and you need a really awesome environment to help you go fast from the get-go. And so project jump starts is another very common engagement that we do. And then also the modernization roadmap, where you have an existing system, none of it's automated, none of it's tested. It's sitting there. Every time you breathe on it, something breaks. You wouldn't dare change any of it. And we help you change that paradigm where you know what to change, and we help you, and we guide you through that, so that your legacy system is no longer cursed by your staff, but you can actually set it up for the changes that are really needed by the business. So give us a call if anything, if setting up your team for success would be appropriate. And I think that I answered a lot of these questions in line. I appreciate the participation. I know I worked in these questions. Oh, there it is. There, in some form or fashion, the same question tends to get asked, and it's a really good question. It's a big model. The question is, how do I get started? Question that's been asked before is, do I need to do everything all at once? Do I have to have this whole model in place all together? The answer is no. Everything that you should do is changing one thing at a time, and be incremental and be iterative. So if you don't have any of this model in place, you start at the center and do a thin slice, and then you move. So automated DevOps pipeline, do a thin slice. Do a continuous integration build. Do some type of build. And of course, make sure your software is in a version control system. Fix any issues with that. Then have a conversation around best practices and write down the practices that you know that you're doing. Then write down what defect removal techniques you're already doing. Then with team workflow, sketch it all out. Make sure you understand it. Then architecture blueprints, a quick whiteboard drawing of the shape of the system, and then cloud operations. Take an inventory of the logs that you do have and where they are, and then start measuring your cycle time around the process of plan, code, etc. And then next iteration, next sprint, come back and figure out, okay, let's take another stab at the automated DevOps pipeline. Let's add on something, and then go through again and enhance it iteratively, enhance your strategy iteratively. Now, if you want a big jump start, we do this a lot. We would be happy to do that for you. We'd be happy to put in place and oftentimes you have a really big beast of a system, but oftentimes you'll have some smaller applications. And it's been useful to a number of clients for us to put in place a comprehensive automated DevOps pipeline for one of your simpler applications as a proof of concept, as a showcase for how it should be put together to assist your team's understanding in how to implement it for the more complex systems. And so that if that's useful, I encourage you to reach out. So that's always a good question. And there's another question: what was the reference for the 4+1 blueprint? So Philippe Christian, you just search for it and search for 4+1 view model of software architecture. And in short, you can also search for 4+1 architecture blueprints, and it's online available. So let's see, another question here is, isn't the process a bit more time consuming and costly as it needs effort from all the developers to perform their parts? So that, not sure I can give a concrete answer to that question, but when you have a well-oiled process where every person knows what their part is, then things flow smoothly. If people are not coordinating and you don't have the opportunity to observe the process, then you don't know. So before you can know if your process, what you're currently doing now, is the perfect thing to continue doing or needs to be changed, you need to equip yourself with the ability to observe the process and how it's going and what are the lead times and how long things are taking in process, so that you can have some data and know whether you're happy with that process or if you're not happy with it. Because if you're happy with it, then what's being done should be done more. If you're not happy with it, you should know why. So I wouldn't advocate you to change the team workflow that is currently in place. I would advocate to make sure that you have the ability to observe it and make that decision for yourself. So I hope that helps. Okay. All right. So another question. I missed this one. 3 elements had to be present in a product, regardless of size. I think it was the 3 defect removal methods, and they were testing, formal inspections, and static code analysis. Those are the 3 defect removal methods that, when put together, reliably get a team up in the high 90%, and oftentimes up to 99% for defect removal. And that's from Capers Jones's research. Static analysis is your C# analyzers, FXCop, ReSharper, inspect code, JavaScript linting tools, any kind of Independ is another one, SonarQube, any static analyzer tools. Testing, everybody knows manual testing, but you also have automated unit testing, automated component level integration testing, and then automated full system acceptance testing, which is a test suite that runs after the system's been fully deployed and is running soup to nuts on its intended target environment shape. And those 3 types of automated testing kind of round out what's there. Although it's not complete. You have to know if you need consistent security testing or performance testing, then you need to add that to the mix. But to make sure you have comprehensive testing, then the formal inspection, a really good implementation of that is just to make a checklist of every time something is changed in the software, you need to go through this checklist. And the perfect implementation of that with the modern techniques is during the pull request process. When there's a branch being submitted back to master and there's a pull request, well, guess what? If the team goes through a checklist when evaluating that pull request, you have implemented formal inspections. So good question. I'm glad glad I could clarify that. Let's see. What do you recommend for automating your SQL Server backup, restore, and deployment script? Perfect question. You'll see some of that illustrated by the DevOps poster that we offered, and the link is in the chat. And the database is absolutely a critical part in your automated DevOps pipeline, because oftentimes if we add a new field to a screen, there's also a new piece of data in a SQL Server table, and those need to be changed at the same time, or you need to sequence those so that there's no downtime and there's compatibility between releases. And so the short answer is that is absolutely critical. You're asking the right question, and we do that a lot of time. Now, anything where you can do it command line, can be part of your automated DevOps pipeline. Because when you deploy, you want the database to be automatically upgraded as well. And so that is a critical part of the automated DevOps pipeline. 2 weeks ago, I think it was, we did a joint webinar with the CEO and co-founder of Octopus Deploy, Paul Stovall. And we have the recording on our YouTube channel. And the topic was database DevOps. And we went deep into all those topics. So Rain is going to put that YouTube link in the chat. And it's on, you can go to youtube.com/clearmeasure. That's the channel, and you can search for the Octopus Deploy Database DevOps webinar. But that's absolutely a critical part. Now, I will say one thing about Restore. Everything in an automated DevOps pipeline is designed to go forward. Nothing is designed to automatically go backwards. When you have a failure and you have to roll back, well, think about it. If you have an automated computerized system to automatically deploy your software and it just failed, how would we rely on it then to somehow do the right thing to automatically roll back, automatically fix the unexpected failure? It's just not going to happen, right? So we want to make sure that we do have backups, because in a restore scenario, in a rollback scenario, that is a failure, and everything that we do in a DevOps process is tiny, is small, and is incremental. And so production deployments become just an aggregate of lots of small changes. And every small change has been deployed multiple times before it gets to production. And we make sure that nothing is being done in production for the first time. So when we're talking about development environments and restoring data to development environments, good follow-up question. There, you can do that command line, but our favorite commercial product for that is Redgate's, the combination, depending on your environment, of SQL provision, SQL clone, and data mask. And so oftentimes we've seen testers maintain, databases of test data that can be restored to development environments. We've seen production data sets be processed and restored to dev environments. What you don't want to do is restore production to a dev environment just raw, because then whatever security controls you had on your data are out the window, because now you have sensitive data in an environment that doesn't have the same controls as a production environment, and you're going to violate whatever audit your organization's subject to. But with SQL clone, we can periodically maintain these data images, and you can refresh them from production. But in the transition out of the production environment, we can run the data mask tool on it, which identifies all of the various columns in the tables that either need to be expunged, need to be masked, or need to be just auto-generated new data, so that we have a data set which is of sufficient size, which is representative of the real world of the full system, but we take all of the sensitive data, any piece of data that could cause us risk, and we just regenerate a different value, or we mask it sufficiently, or we just expunge it completely. And then that can automatically restore to development environment. We often find that clients want that on demand. We haven't seen a situation where we do a complete large restore automatically every time. Often people want to be able to press a button. However, an exception to that is automated test suites for performance, where you would provision a development environment for automated performance testing. Then you would need to load that database environment with a large data set, and then run some performance tests over and over again with every build and every pull request, so that you end up yielding a line graph of how long it takes for the test suite to finish, what the relevant performance counters were, and then build over build, you can see on a line graph if some of the numbers start to go in the wrong direction, because oftentimes it'll work on a developer's workstation, it'll work with a little bit of data, but then at scale or at larger data sizes, you do something and then unexpectedly some of the performance characteristics change. And so that can be useful. But for the restore, Redgate is definitely the company to turn to from a product perspective and integrate that back from production into development. And we do a lot of implementation for, actually we're a very active US consulting and implementation partner for Redgate. And whether it's SQL change automation or any of the other products, we integrate that a lot. All right, great questions. Let me just check to see if I missed any. Lot of interest in the ebook, in the poster, and all right. Well, thank you very much for being such a involved audience with great questions I was able to work in during the webinar, and also great follow-up questions afterward. I appreciate your time. And this is my contact information on the screen. I'll leave that up for a little bit. Thank you so much. Get in touch with me directly if you have any questions. I'll be happy to talk to you one-on-one. And yes, that is my phone number. So I hope you'll have a great week, and we'll talk to you soon.